So just a little on the diode or gate that determines whether the solar panel or the USB micro B connector dominates. So what happens, say you have a charger, just a regular charger like you use to charge your cell phone, and you got that plugged in here, and consequently the charging circuit derives power from the USB connector. Well, say you plug in a solar panel at the same time through this barrel jack. Well, if the solar power, see, you have voltage at the anode, comes out here, so whatever, if the solar panel voltage is higher than the USB voltage, then this diode here will reverse bias, allowing just the solar panel to charge the battery. Let's get our parts together and load up this 18650 charger that has solar charging capability. First, we'll load up the SMT parts, starting with the ICs. Here's the protection IC. Here's the Schottky diodes. Here is the DC to DC converter chip. This takes the battery voltage and steps it up to 5.1 volts. Here's the charger chip. It has a maximum input voltage of plus 8 volts. So when you attach your solar panel, make sure that it's less than 8 volts. Here's the dual transistor that's used as part of the battery protection circuit. We'll go ahead and plug down a couple of 1206 green LEDs. Okay, maybe that was more than one. Yeah, it was 3. Okay, let's solder these parts on. Okay, we got the integrated circuits and a few of the LEDs soldered in. Notice also soldered in the USB-B, micro B connector. The reason I did that is you want to solder this connector in before you solder in this diode. Why? Because it gets kind of hard to get the solder iron tip into that space. So do the USB connector first, then solder in your diode. Now we'll load in the passive components, resistors, capacitors, and inductors. Okay, we have the board all loaded up. So now let's go wash the board. Show you what that looks like. So there's the red light showing that it's not quite completed the charge. Now this is pretty close to charge, so let's see if the green light comes on. Well, maybe while we're waiting for the green light to come on, showing a complete charge, we could talk about why you would want to spend more money, because you can buy these kind of chargers for $1 roughly, and so economically doesn't make any sense. But if you're a designer of products, or you want to be a designer, what I would like for you is that you're able to put circuits together. First of all, go through the design cycle. So you're downloading the Gerber files, which so far I've put all the ones on my website for free. Send them to your PCB manufacturer, get the boards, take the bill of materials, it's also given for free, order the parts, and then build these circuits. So you're going to practice your soldering skills, you're going to practice ordering the PCBs, and you're also going to practice downloading engineering files. So you do this enough without actually doing designing at this juncture. What you're going to be doing is getting used to the design cycle that is used by many engineers, including myself, for over about 50 years. And you're going to learn how to do this without spending 6.5 years in college, going through a 9-month high-altitude radar course, taking a correspondence course in electronics many years ago, and many other things that I've had to do in order to get up to the place where I could design circuits. This is a massive shortcut, and you would have to determine what that price is, because to me, this is a bargain course in electrical and electronic engineering. If you're a mechanical engineer, you probably don't have another 5.5 years to devote to taking electrical engineering in college, but you still need electronics in your products. And so this channel is designed to give you as much information or as much practice as possible. You determine what that's worth. One thing we can do is let's break these apart. Okay. Gently press together, and there you go. Oh, look at that. Green light at the same time. Okay, this charge is complete. Now let's see if this thing puts out 5 volts. Okay, let's plug in our adapter. Now we have 2 convenient points from which we can measure the voltage on this charger. And here we have volts right here. And let's see what this reads. And we have, oh, help if I turn it on. We have 5.1 volts. Okay. So now the next goal so we have this one, we're going to put this to the side. And this other one we broke up, did not charge. So let's put this fully charged battery in there. And first, we're going to see if we get 5 volts coming out at the output. And we get 5 volts, 5.1. Okay, so we know the output circuit works. So what we're missing is the input circuit. So let's apply a charging voltage to this thing. And turn this off. Turn the output off, rather. Notice we don't get a charging light. So let's start there. First step is to put this thing under a magnifier. See, look for any obvious issues. So we're back, and here in the charger part of the board, this is the charger IC, and right here is the limiting resistor that sets the charging current. Well, I had a 2 ohm resistor in there. Somehow that snuck through. Now I got the 2K. Now let's see if that fixes the ability for this circuit to charge. In fact, we'll use our charger that we just tested. Let's plug that in. And we'll turn on our charger. And then we'll spike this a bit. And nothing. Okay, so I got a little more troubleshooting to do here. Okay, so we have good output, but we're still not charging. All right, that's our symptom. Get back with you. We're going to go ahead and take this working one and plug it into the solar charger. So here's our solar panel input. And now we don't need this adapter. So we'll unplug this. And we'll take that 2.1 millimeter barrel plug. And plug that in. And notice we're charging. Cool. Solar charging works. Here's the output of the solar panel right here. There we go. Solar powered power bank, or rather solar charged power bank. So here we have the 2 built units built from this printed circuit board. Notice you got 2 on there, so we made 2. Turns out on the second one, what I had done is, let's 5.17 volts. And then this one, .17 volts. So on the second one, it didn't work right out of the box, and it come to find out I had failed to solder the inside pins. I'd merely tacked this USB connector onto the board using the pads that are mechanical pads to hold the connector onto the PCB, and then I failed to solder the actual connections on the inside. Let's see if we can see that. Well, they're soldered now. So both of these were plugged into solar panels and successfully charged these 2 batteries.